The Convair XFY-1, also known as the Pogo, was a unique experimental aircraft developed by Convair in the early 1950s. One of its most distinctive features was its upside-down propeller configuration, which set it apart from traditional aircraft designs of the time. Let's explore together some of the significant features of the Convair XFY-1 in today's exciting video. One of the most remarkable aspects of the XFY-1 was its capability to take off and land vertically, much like a helicopter. This capability was successfully attained by employing a sizable contra-rotating propeller positioned above the fuselage. With the help of the propeller, the aircraft could soar vertically, enabling it to take off from compact platforms or ships without requiring a conventional runway. The XFY-1 had a one-of-a-kind setup where it would stand on its tail on the ground, only to smoothly shift to a horizontal position when soaring through the skies. They picked this setup to ensure the aircraft could take off, land vertically, and still fly smoothly horizontally. Two propellers were mounted on a single shaft, one rotating clockwise and the other counterclockwise in a unique arrangement. With this configuration, there was enhanced lift and stability when flying vertically, along with better efficiency and control when flying forward. Behind the scenes of the XFY-1 was a mighty Pratt & Whitney R2800 radial engine, a trusted powerhouse found in numerous aircraft during that time. With a sophisticated gearbox system, the engine powered the contra-rotating propeller, enabling vertical and horizontal flight. For enhanced maneuverability during takeoff and landing, the XFY-1 featured a swiveling exhaust nozzle that could redirect the engine thrust downward. With this feature, the pilot could easily control the aircraft's altitude and remain stationary while flying vertically. Stability and control. Even with its unique design, the XFY-1 proved remarkably steady and easy to maneuver in vertical and horizontal flight. With its cutting-edge flight control systems and stability augmentation devices, the aircraft was designed to help the pilot navigate smoothly, especially during the crucial shift from vertical to horizontal flight modes. Legend has it that the XFY-1 was a daring creation designed to push the boundaries of aviation by testing the possibility of vertical takeoff and landing for military aircraft. It was a time of great promise for VTOL operations, but also a period filled with technical hurdles and constraints. Challenges like engine reliability, control responsiveness, and pilot workload loomed. On the XFY-1, the propellers spun in opposite directions and had blades that the pilot could adjust to enhance performance at various stages of flight. With this feature, pilots had more freedom and power to adjust the aircraft's thrust output, especially when switching between vertical and horizontal flight modes. With its innovative features, the XFY-1 was crafted to be compact and lightweight, allowing it to operate from small ships or tight landing spots. Its small size made it simple to carry and set up in far-off places, giving it more options and adaptability. Back in the day, the XFY-1 was designed for subsonic flight, but the clever Convair engineers decided to push the boundaries and see if they could make it go supersonic. Proposals were made for supersonic versions of the XFY-1, with swept wings and more robust engines. Unfortunately, these plans never came to fruition because of financial limitations and changing military objectives. The cockpit of the XFY-1 was meticulously crafted to prioritize a pilot's visibility and comfort. The cockpit provided a panoramic view in every direction, enabling the pilot to stay fully aware of their surroundings during vertical takeoff and landing maneuvers. The cockpit controls were carefully designed to make it easy for the pilot to use and access them, reducing their workload during essential parts of the flight. Extensive flight testing was conducted on the XFY-1 to assess its performance and handling in different flight conditions. During a series of daring flights, test pilots carefully evaluated the aircraft's stability, control responsiveness, and engine performance, gathering crucial data for the advancement of VTOL aircraft. Even though faced with technical hurdles and setbacks during testing, the XFY-1 showcased the promise of vertical takeoff and landing technology and laid the groundwork for future progress in this area. One of the roles envisioned for the XFY-1 was to serve as a carrier-based aircraft for the United States Navy. With its unique ability to take off and land vertically, it was the perfect choice for missions on aircraft carriers, especially when runway space was scarce. Yet, the Navy chose different VTOL aircraft designs, like the Lockheed XFY-1. This aircraft had a more traditional layout and transitioned to horizontal flight using lift jets mounted on its wings. Although the XFY-1 never made it to production or active service, its impact can still be seen in future VTOL aircraft and technological advancements. The XFY-1 program played a crucial role in shaping the design of the renowned VTOL aircraft, like the British Harrier and the American AV-8B Harrier II. The XFY-1 sparked continued exploration and advancement in vertical takeoff and landing technology, leading to the development of uncrewed aerial vehicles equipped with VTOL capabilities. With a keen awareness of the dangers involved in vertical takeoff and landing operations, the XFY-1 was outfitted with safety features to safeguard the pilot and reduce the risk of accidents. Among the remarkable features were redundant flight control systems, emergency ejection seats, and a cockpit design built to withstand crashes. Furthermore, thorough pilot training programs were implemented to guarantee that XFY-1 pilots were skilled in managing the distinctive challenges of vertical flight operations. Not just an experimental aircraft, the XFY-1 was also designed for a range of operational concepts, such as close air support, reconnaissance, and anti-submarine warfare. With its unique ability to take off and land vertically, this aircraft provided strategic benefits in various missions, enabling it to be deployed from remote areas or platforms near the front lines. Yet, the XFY-1's practicality for these missions could have been improved due to VTOL operations complexity and technical challenges. Equipped with advanced flight control systems, the XFY-1 could seamlessly transition between vertical and horizontal flight modes. Among the components were gyroscopes, accelerometers, and advanced control algorithms that work together to keep the aircraft stable in crucial flight moments. Moreover, the XFY-1 was equipped with fly-by-wire technology, enabling precise control inputs and improved maneuverability, particularly during vertical takeoff and landing operations. The XFY-1's fuel system was crafted to meet the specific requirements of vertical takeoff and landing operations. Great care was taken to manage the fuel effectively, ensuring enough reserves for hovering and transitioning to horizontal flight. The fuel tanks were cleverly positioned to ensure the aircraft's balance and to have minimal effect on its performance throughout various stages of flight. The XFY-1 was carefully crafted with the harsh maritime conditions in mind. The aircraft's structure was shielded from saltwater exposure and harsh weather conditions using corrosion-resistant materials and coatings. Furthermore, great care was taken to design engine intake and exhaust configurations that would prevent the intake of foreign objects and guarantee dependable performance in maritime conditions. Originally designed as a fighter aircraft, the XFY-1 showed promise for various mission roles beyond air combat. Its ability to take off and land vertically made it perfect for reconnaissance, aerial refueling, and close air support missions. The value of the aircraft as a multi-role platform was highlighted by its versatility and adaptability to various mission profiles, showcasing its ability to operate from unconventional locations. The cockpit of the XFY-1 was meticulously crafted to prioritize pilot comfort and efficiency, considering human factors. They ensured the seating was comfortable, the controls were easy to use, and the instruments were complete to help pilots during long flights. Moreover, the cockpit was designed to be pressurized and climate-controlled, guaranteeing the pilot's comfort and safety during extended high-altitude missions. Equipped with state-of-the-art communications and navigation systems, the XFY-1 was ready to meet its operational needs. With the help of radios, navigation aids, and data links, seamless integration was achieved with ground control stations and other aircraft during multi-aircraft missions. These systems help provide a clear picture of the situation, coordinated missions, and improved communication with command and control elements, ultimately boosting the aircraft's performance in challenging operational settings. In the early 1950s, the Convair XFY-1, also known as the Pogo, showcased the remarkable ingenuity and innovation of aerospace engineering. The XFY-1 was a groundbreaking aircraft with its unique upside-down propeller setup and ability to take off and land vertically. It challenged the norms of traditional aircraft design and set the stage for future innovations in vertical flight technology. Through a series of trials and tribulations, the XFY-1 showcased the promise of vertical takeoff and landing technology for military purposes, despite facing various technical obstacles. With its compact size, advanced flight control systems, and ability to take on different mission roles, this aircraft demonstrates its versatility and operational flexibility.